Our next two speakers are Berman and William Faschan from Cobb, Freeman and Partners. They're going to talk to us about iconic, luxurious, super tall, sustainable structures. Please.
I think when we all come to a conference like this to hear about super tall buildings, we expect to hear about breakthroughs, and a lot of those come in terms of technological advances or material advances, breakthroughs. In this case, in the context of building a super tall building in Mumbai with admitted concerns about the capabilities in local construction and availability of material, our effort is actually centered on making breakthroughs that are actually making the building as conventional as it can possibly be and still be a super tall and iconic building. We're also going to talk, I'm speaking with Bill Faschan, who's my structural engineer. We're going to talk about the very close collaboration between structural engineer and architect to solve the building and make it what it needs to be. A little bit of context first, because context is essential. We're on a 17-acre former mill site in central Mumbai. Central Mumbai is characterized by almost 60 former textile mill sites. These sites, by and large, ended actual textile mill operations by about 1980 and sat vacant primarily for upwards of 30 years. The mechanisms and both politically and economically didn't exist for development to happen. As we found our site in early 2009, you can see the mill facilities still there, and indeed, when we walked onto the site only a few days after our client gained access, after closing all of the real estate issues, we found really striking and interesting circumstances, literally sort of left the way it was the last time the place had operated. And of course, sort of visually arresting circumstances of nature and building sort of combined. And the city, of course, had grown around it, thriving, quite dense, quite populated. And this characterizes the development situation in Mumbai generally, whereby tall buildings are sprouting like weeds amidst former mill buildings, which most of which probably have the same fate. Not a lot of organization, not a lot of planning, not a lot of logic to how the city works. And I talk about this a bit because our efforts at building tall buildings, of course, deal with structural issues and technology and the engineering of it, but we have a sort of deep commitment that tall buildings have a special responsibility not only to make a statement on the skyline, but actually make a statement and a positive impact on the life of the city as they meet the ground. So this is the site plan for the 17-acre site. The program for the site as we started involved somewhere between 7 and 8 million square feet of building, largely residential, also mixed use, a lot of parking. And what we found as we started looking at this site is that it's extremely well located relative to Mumbai, but it has quite a small amount of frontage actually on streets. And we talked with our client about how to approach this issue and essentially said, well, this is a very good location, but it's not a place. And with our interest of contributing to the life of the city and also utilizing the site quite efficiently and making the most real estate value for them, we actually made one very important move, which was to strike a road or a street or a boulevard across the site, and to say that this is the place, this is the location, this is actually the identity of the place. What that also does is divide the site very cleanly and very effectively into a zone which can have public uses, parks, retail, street life, active street frontage, and still maintain quite a bit of space necessary for the actual mixed-use development itself. And the master plan, as it sort of completed its initial stage, with the designation of 3 already quite tall residential buildings, a group in yellow, mixed-use buildings in blue, the red indicating retail and street uses, and the green indicating public park. Fast forward about a year of design into a variety of buildings, and we still have the beginning of the development of a street life which connects the whole complex to the city, a boutique office building about 250,000 square feet, a mixed-use tower which is currently in schematic design, and of course a group of residential buildings, residential towers, the tallest of which is World 1, which is primarily the subject of the presentation. But it's important, from my point of view, to go through how the site works and how, in particular, the density of the site required a response that couldn't start with the tall, iconic building that the client wanted to build. It had to relate to something. So how did it get to be the way it looks, and you're seeing in the three-dimensional images more or less the final design which is under construction. And it's interesting, I think, in the context of Adrian Smith's comments this morning about his interest in the three-leg plan and the sort of lineage through architecture. We didn't start here. We didn't quite back into it, but it was more the confluence of a very dense site which needed to accommodate a whole lot of apartments in conjunction with structure and other kinds of considerations. Along the way to sort of finding our way to that solution to the residential development in these towers, of course, we looked at different typologies, a typical sort of 90-foot square point tower. We looked at mid-rise, which really wasn't so mid-rise because of the sheer amount of housing that was trying to be put on the site. We looked at mixtures of high and mid-rise, but essentially came back, and to the answer I think we always knew, which would be that this would be a group of tall towers. Already at this point, sort of also indicating that there was one special and dominant tower among the family of 3. Now, to take this sort of diagram, which is a bit generic, and turn it into what it needed to be in the context of Mumbai, we spent a good deal of time looking at some local precedents. These are floor plans from a variety of typical high-rise buildings in Mumbai from the early to mid-2000s, in which we drew a few early conclusions. One was that almost all these buildings were the sort of logical maximum extrusion of lower building typologies. Single groups of elevator banks, no high-rise and low-rise, building aspect ratios in terms of this one in particular, which couldn't really be extruded any further. We also found, by and large, and this is not a surprise in terms of buildings that are 100% residential usage, that the buildings are designed almost entirely from the inside out. And so there were a lot of aspects of this, knowing the density and the height that we were going to achieve, but also the aspirations of building an iconic building on part of our client that we knew could not apply to what we were doing. And so that we had to begin to make a sort of new typology within this context, which certainly wouldn't be the kind of typology you would find somewhere else in the world, but also wasn't what you already found here in Mumbai. But at the same time as we knew that we had to make improvements, we also knew that this inside-out design approach and our clients and their competition's very sort of clear sense of the residential market meant that we had to look at these quite closely, and that we had to find a number of ways of achieving things that are actually quite desirable about these buildings. Many of them have floor-through units. Many of them have extensive balconies. They're actually, in many cases, quite large units. And so we took these typologies and began to make our own sort of prototype. Generic in terms of what it predicted as architecture, but embodying a number of aspects that we thought would have to carry all the way through. The size of the apartment is extremely important. There was a very small range in which the apartments could be judged to be marketable, meaning they had to be at just the right size, just big enough, but not too small to fit certain area ranges. The buildings that we looked at precedents almost entirely had bathrooms that were at the exterior, which is fairly typical in Mumbai. Because of the density on the site, we knew we couldn't waste space on the outside, and so we made an early an early decision that they would be interior, which was, it's not a huge breakthrough, but it is a different from what was the norm. There's our high-end apartments, and our client wanted balconies in every single room. Relationships between family and public space, servant space, service, all had to be kind of respected in a way that in most of the super tall buildings we look at, we find mixture of uses, and that's the way in which shape and appearance begins to be changed from bottom to top. In this case, we had very discrete building elements, and we also had a circumstance in which a taut curtain wall, for instance, was not going to be the solution. We also knew, and this is sort of the key that started us into actually finding a suitable building form, we also knew that these diagrams at the bottom are actually Excel charts, and the pro forma was such when we sort of started to deploy this on the site, it became clear rather quickly that we needed 6 units per floor at the bottom of at least 2 of these 3 buildings. And so, knowing the size of the units and that we needed 6 of them, we knew we needed 21 bedrooms, 6 living rooms, 6 kitchens and service areas per floor. And we started to do a kind of calculus where we take that prototype unit in red, start to imagine how cores might work, and they didn't want more than 2 units, and 2 apartments entered from 1 set of elevators, an additional complication. We started to do a kind of calculus of, well, if we need that much perimeter and we have to figure out a logical core, what are we going to do? And of course, that's how we kind of, between site and program, ended up with our 3-leg plan, with, of course, an idea that structurally this would also have advantages as we moved forward. And so you can see as we begin to take that diagram and start to put the shape in it that you saw in the building itself. And so we had a scheme, let's say, at least for the plan of the building and the basic volumetrics of the building, but we didn't have a structural scheme yet. We made the early proposition architecturally that a cage of closely spaced columns at the perimeter with proper connections to the interior was a likely approach to deal with lateral forces and to be consistent with what we needed to do in terms of residential plans. And of course, the strength of concrete normally used in a place like Mumbai isn't particularly high, and those columns at the bottom of the building were quite big. We looked at embedding steel in the columns, which had a very marginal reduction in the size of the columns, and fairly quickly rejected that as an approach for its complexity in construction. But during this time, we also had essentially quite refined the actual unit plans, and to a degree that we were quite happy with them, and our client was happy with them in terms of all bedrooms essentially having full-length windows and balconies at their edges, and the sort of payoff of a shape like this, which was that the living rooms, dining areas were at the perimeter. Now, of course, none of us liked the two giant columns that were in that living room, and so to this point, our structural engineer, we told them that they were being too polite and too cautious with us and sort of taking our lead. And I said, you know, forget everything you know about this except the shape of the building and the volumetrics, and what would the perfect structure be. And we sort of had a sense of what the answer might be, and of course it was a sort of 6 mega columns, and Bill can describe this better than I can, 6 mega columns connected to the core in a strategic fashion. But of course, given the calculus that I talked about before in terms of needing a certain amount of perimeter, this was effectively taking 6 bedrooms out of the mix, and so the building didn't work anymore. And we played with that further, for instance, to say, well, maybe we could configure it a little bit differently. But those are still actually quite large, and we were losing floor area in a place where we couldn't afford to lose floor area relative to residential plans. And so, given these and what we were working with, and you've also seen this in sort of evolving in 3 dimensions as I've shown the plan, we started talking about a hybrid system and what would the possibilities be. And of course, I should have said that, done that slide. I'll go past that. So what we ended up with as an approach that works very well for structure and very well for the apartments is actually a sort of hybrid megastructure in which we gathered 6 columns in the concave surfaces and gathered 3 in the convex surfaces, and we're able to open this area up with a single small gravity column which gets taken out at each tier. The result of that visually for us was quite exciting and quite important in that the gathering of the columns, 6 columns in the concave, leaves one column, the single visual element, which goes from top to bottom in each tier is at the inflection point. Tier 2 plan working with the hybrid structure, and Tier 3 in which there are duplex apartments occupying the entire floor plate, and some images of the building where you can see the effect of the gathered columns, the stretch, and the columns at the end, in a way energize and enliven the form in a way that our initial ideas couldn't do. A few more images quickly. And several views inside and out showing how the living rooms and bedrooms work relative to structure. At the living rooms in the lowest tier, the second tier with larger apartments and a living dining area with a panoramic view, and then at the very top of the building there are, I think, a dozen of these duplex units where the sort of payoff of the structural configuration is especially welcome. And on the skyline, and now for real substance.
Well, I don't know. I thought that was a lot of substance. Well, Jay has made the premise to you that together we've created a building that works well from an architectural perspective, from a structural perspective, and is well integrated. I think the last slides he showed you, some sense the architecture speaks for itself, of course, but let's look and see how well we did. So this is just some basic data that particularly those structural engineers of you out there can sink your teeth into. The first line basically tells you that in Mumbai, for a variety of reasons, buildings are quite heavy. So you have a really dense, heavy building to start with. Wind loads are pretty comparable to here, maybe a little windier than here in Seoul, New York, very comparable there. I would say that the speeds that are listed are, by some opinions, conservative. Seismicity is moderate. It's in sort of the middle of the range of the Indian spectrum. And in IBC terms, those of you who would speak that in terms of data, you have some data there in terms of IBC. It's more or less, again, comparable to New York, I would say. In terms of foundations, Mumbai is a mixed bag. It's former islands filled in, so depending on where you are, you have different conditions. But generally, if you go deep enough, you hit really good rock. So we had a combination of weathered rock and then solid rock down maybe 30 meters. In terms of the structural system, I mean, some of the images Jay showed you give you a pretty good idea. Here's a few more. Obviously, the grouped perimeter columns. You see some shear walls, which are sort of along the splines, like some of the other buildings you've seen today. Additionally, there are some walls that are on the perimeter that overlie where the one tier sets back below, on the tier below. Not as well organized as some other buildings, but still a system that allows us to deal with the stresses that occur at those intersections. Here's the more difficult one, the tier 2 sitting on tier 1, and we'll just go inside a little bit because the wall that goes across the top of tier 1 is transferred out by a series of simple 3-piece trusses, steel trusses. We try to use as little steel as possible in the Mumbai market. It's seen as a significant premium as well as something that the local contractors at least do not have a lot of good experience with. In terms of the metrics for how we did, I thought these were some of the more important ones. You know, in a tall building, as others have said today, obviously keeping the differential shortening of the individual columns and walls to a minimum is an important consideration. Dealing, of course, with the wind and seismic loads, and then achieving the requisite level of human comfort in the wind. In terms of the dead load distribution, you can probably see from this chart that, you know, the bubbles represent sort of general magnitude of the load at different places in the footprint. This is at the foundation level. Obviously, you have 3 tiers, which are at different heights, so much greater loads. But hopefully you can see from this diagram that the distribution is relatively even. You know, obviously one side is more heavily loaded than the other, but the distribution of the load is pretty good. If I just back up a second, if I can figure out how to do that. In terms of the magnitude of the load, the highest loaded, most heavily loaded column under gravity is 136,000 kilonewtons. That will be a reference point for these other slides. Now, if we look at the wind, you see a pattern which represents that the whole of the building is acting together. You see the peak stresses, the blue, the largest compressive stress due to wind, and the white circles, the largest tensile stresses due to wind alone, are at the perimeter, and there's again a relatively gradual distribution between the perimeter and the middle and to the other side. The magnitude of the wind load now 53,000 compared to the 136,000 you saw on the prior slide. So the wind loads are large, but there's no tension at the bottom of the building. Same thing, different wind direction, same sort of conclusions. In terms of seismic, another point of reference is in terms of the numbers, 24,000 kilonewtons. So as with some of the other buildings have been shown here, in a moderate seismic zone, the wind load is basically double the seismic excitation. In terms of the deformations of the building under its own weight, this is the results of a construction sequence analysis where, as is typical, you generally get the largest degree of lean in the building associated with differential effects at more or less partway up the building. 100 millimeters is not a bad value in my opinion. In terms of differential shortening between individual columns, if you go to the roof and look at the relative values, the Greatest difference is between the 2 points circled, which is a significant difference apart, and the differential, including all long-term effects, 65 millimeters. So again, I think a quite acceptable result. In terms of wind load deflections, relatively normal degree of stiffness has been achieved. The deflection is the height over 495. In terms of the accelerations, we did result in the need for a supplemental damping system in the building. You can see from this chart that the periods are relatively low, so despite the heavy weight of the building, it is quite stiff. Despite that, we did need a supplemental system, and the building will have a sloshing water damper system, which seemed to be the right solution for the Mumbai market.
2 minutes.
In terms of where we are in the construction, we're at the foundation level today. This is the foundation plan, so we are pile supported, but rather short piles. This is a relatively recent photograph of the piles in place and coming up more or less to today. The raft is in progress. Some of the raft at this point is cast. This is not completely current. And that's where we are. So maybe in a couple of years, if you invite us back, we'll tell you how the story ends.
Our last two speakers